In 2010, 40 turtles were reintroduced into a wetlands park. By 2017, the population had grown to 110 turtles. Assuming the population is growing exponentially, write a function p of t representing the population p of turtles over time t. Since we're told that the population is growing exponentially, we want a function of the form p of t is sum a times b to the t. We have to figure out the a and the b that make this work. And what we will do is we will let t represent the years since 2010. And this is a good choice because now, since t is the year since 2010, we have an initial data point. In 2010, there were 40 turtles introduced to the wetlands park, so that means we have the point 0, 40. The curve must pass through the point 0, 40, and then we also have the point in 2017, the population had grown to 110 turtles, so we have the points 0, 40, and since t is the time in years since 2010, and 2017 is 7 years removed, so we have the point 7, 110. So first, let's use the point 0, 40. That means when t equals 0, the population is 40, and so then letting t equal 0, a times b to the 0 would equal 40. Recall that raising any non-zero number to the 0 power is 1, and so we have a times 1 is 40, and so then a is 40. So we now know that the function takes the form p of t equals 40 b to the t. So now we just have to figure out the b value. All right, we'll use the other data point. When t is 7, the population is 110. So now 40 times b to the 7th power is 110. So now let's solve for b. b is being raised to the 7th power, so we'll need to use a radical or a rational exponent to evaluate that. To solve for b, I should say. All right, so first let's divide by 40 on both sides. And so then b to the 7th, 110 divided by 40, let's just write that as 11 over 4. You could use a decimal number as well. And so then b would be the 7th root of 11 over 4, right? Or, which is the same as 11 over 4 to the 1/7 power. Now, I can't do that calculation in my head. So let me bring up a calculator here, and this is just, whatever one is on my computer here. So let's calculate 11 over 4. Now, I don't have a general root button on my calculator, so I'm going to use the 1/7 power. Let me calculate 11, divide that by 4, 2.75. All right, now I will raise that to the 1/7 power. I need to use parentheses around that 1/7. So parenthesis 1 divides 7, close the parenthesis, and hit equals. And so then 2.75 to the 1/7 power, b is, I'll round that to 4 decimal places, 1.1555. So then my conclusion is that my exponential function, p of t, is 40 times 1.1555 to the t.